So, where does mass come from? I'm going to explain. These two objects move synchronized with each other. Now I'm going to introduce what's called the Higgs field. It's made up of Higgs particles, which are these gray things, gray little small particles. The lighter one is what would happen if the Higgs field wasn't there. So it's going to be immune to the Higgs field, but the darker one is going to actually sort of feel the Higgs field.
So the lighter one is a photon, for example.
Yes. And you can see it's slowing down because of these.
The darker one is slowing down.
Yes. These little thingies. Again, this is not accurate because you can see it's now already moving that way, but it's... And if we introduce a lot of these, well, then it becomes more close to Brownian motion. But anyway, so this is just a model, but also it's gonna, if something has mass, it won't slow down like that. It will just continue moving at its regular speed. But when it tries to speed up or slow down, it's gonna resist that. So this is closer to Brownian motion. If I just can do this. So now I just have a single one. Now it's meant to be that there are a lot of them. Now, if I draw where that particle goes, I'm going to do geological history. I'm going to say history equals a new array list with p-vector objects in it. And here I'm going to say history dot add position. So now if I loop through that when I'm drawing it, so I'm going to say stroke um 0, 128, 255, let's say. And I'm going to say fill begin shape. Then I'm going to end shape. Right? Can't type today. For p vector. Oh, by the way, I have to copy it, so I'm going to do dot copy for p vector v of history. I'm going to add what should I add? I'm going to do vertex, index, if you know why. Okay. Hopefully now. Wait, what? Okay, yeah, I only need to actually display this for, I'm going to say, Boolean keeping track. And I'm going to say keeping track equals, okay. I'm only gonna do this if I'm keeping track of the history. Same thing when I'm drawing it. Now, I do want to keep track of the large one. And I don't want to keep track of the smaller ones. Yeah, now I can see it traces out a path. So if I have a lot of these, it's closer to brownian motion, but it occurred to me that it's gonna work with the Higgs field also, if there are a small number of them, and
But can we actually, in physics, can we talk about a number of Higgs bosons, or is it completely not appropriate to even think about of a number of bosons?
Yeah, it's basically like counting the number of quarks in a proton. You might think that a proton has 3 quarks, but no, it has like a few. That's only the baryon of the proton with the valence quarks, and then there are a lot of mesons inside that proton as well. And you can't even count how many quarks there are in a proton.
In other words, other places where there are like more Higgs bosons, that the Higgs field is denser, or is it more or less homogeneous everywhere? Because you're saying I added some more.
Well, yeah, that's actually a good question. I think it's homogeneous. Okay, this is what happens when we have just one particle.
But we're just playing around with it because this is probably completely unrealistic, right?
Yes. So if I go ahead and press K, because it just resets us, that it doesn't get so slow. So quickly. Or at least if I feel like it's getting a little bit slow, I can make it faster again.
Did you build it on top of a processing example?
I built it on top of the circle collision example. It's the same example where I built the corona simulation from. So I basically only ever use processing if I want collision detection between circles, because anyway, let's do 2 particles. Let's see. Let's see. We have these 2. And it looks a little bit more random. Although it's still sort of made up of straight lines and stuff. I'm just gonna clear it so that it becomes fast again.
When did the Higgs field appear? Right after the Big Bang?
I think we think so.
So it's like the other bosons?
Well, the other bosons actually didn't appear straight after the Big Bang. So, I didn't actually know this, but like right after the Big Bang, the electromagnetic force and the weak force were just one force. So, it's called the electro-weak force. On the other hand, gravity split apart from the other forces really early. And then in the middle, the strong force split apart in the electromagnetic force.
But some people consider electro-weak force one force up to this day, don't they?
Yes. But there are some properties of the weak force that electromagnetism don't have. Didn't have, so we're gonna... Anyway, let's go up to 5 particles. First, I just want to see the overall behavior, so I'm not going to clear it as slow as it might get. Well, still sort of straight liney, but a little bit more, jagged. Ten? Now is really sort of starting to have them interacting constantly. The key press doesn't affect how the particle moves. It only affects the history of where the particle is. I just clear it so that it gets faster. The program, I mean. Not the particle itself. Anyway, let's see. 20 particles? Okay, now it's really starting to get a little bit more random. 50 next. There are still some stretches of it going in a straight line, but it's now it's sort of curving a little bit more constantly, I guess. By the way, I haven't... Wait, what?
You went off the screen.
Anyway,
These are 100?
yes. Now let's go to 200. Now it looks more like the particles are sort of guiding the circle around.
You're every time pressing K.
Yes. Or actually, I can press any key, but
Any key. Okay.
you can.
To clear it.
Right. 500, I think it will start to. Yeah, I think I'm gonna remove the history entirely. With 500 particles, it just goes crazy. And with 1,000, I think it won't even be able to place the particles in the beginning without it going crazy. Yep. Well, almost, but anyway. I'm gonna leave this at 100. Okay, that was the Higgs field and a model of it. That frankly has more to do with Brownian motion than the Higgs field.